5.2, the current in series circuit. So here we have N resistors connected in series. As you can see, there's a voltage source Vs connected to these N resistors. And if we let the source to conduct, the conventional current flows from the positive terminal towards the negative terminal. And then it flows through this wire, turns, and then continue turn again, and the current goes through each resistor. So it goes through R1, R2, R3, and a few resistors, and then it passes through the last resistor, Rn. And then turn, continue, turn, and return back to the negative terminal. If we just randomly pick a point in this circuit, such as here, and measure its current, let I to be the current, and then we measure at different point, such as here, there, and at these places, we realize the current is same at any point. In other words, the current is uniform. It is constant. The strength or the speed of the current is same at anywhere in this series resistor circuit. This is a very important concept. So now let's see how to apply that concept to solve circuit problems such as here. This circuit has three resistors, R1, R2, R3. They connected in series. Three resistors connect to a single source that's called Vs. We want to know the current in this circuit. So put the circuit to the side, and then let's find the total resistance first. The total resistance RT equals to the sum of three resistors, R1 plus R2 plus R3. Substitute the value for each resistor. That is 1.0 k ohm for R1 plus 3.0 k R2 plus 6.0 k ohm for R3. If we add them up, that is 10 kilo ohm. So the system has 10 kilo ohm resistance. The question is, what's the current in the circuit? We know if we replace these three resistors by just one resistor, that one resistor's value is 10.0 k ohm. Now the circuit looks easy because we can apply Ohm's law. Ohm's law is the relationship of voltage, current, and resistance. Here we know voltage, that is 12 volt. The resistance is 10 kilo ohm. So we can use the Ohm's law current formula to find the current. That is I equals to Vs over RT. The source voltage divided by the resistance of the system, the total resistance RT. So now substitute the values into the corresponding variable. 12 volt divided by 10.0 kilo ohm, that is 12 volt over 10,000 ohm. Use calculator. The number is, we get 0.0012 amp. This is the correct answer. We can even make the answer better using engineering notation. So move the decimal point to the right 3 times. That number portion is 1.2. Since we increase the number, we need to reduce the prefix by 1,000. So this is 1.2 milliamps. For our class, changing the number to engineering notation is optional. So either 0.0012 amps or 1.2 milliamp, both, or 1.2 milliamp, either answer is right. Both answers are right.